Hello students, my name is Jessie. I am from Government Degree College, Khairabad, Faculty of Chemistry. Today I am going to teach colorimetry and spectrophotometry. It's a topic from paper 6, that is for 5th semester students. Students, before going into the chapter, I want to teach you the basics of chemical methods of analysis. I think you all have an idea of these chemical methods of analysis. Chemical methods of analysis is classified into qualitative chemical analysis and quantitative chemical analysis. Qualitative chemical analysis is a branch of chemistry that deals with the identification of elements present in a sample. You all might have done this in inter-second year practicals where you have done inorganic qualitative analysis as well as organic qualitative analysis. In inorganic qualitative analysis, you were given a salt and asked to find out the anion and cation present in the salt. And if it is organic qualitative analysis, you were asked to find out the functional group present in the compound. So these all comes under qualitative chemical analysis. Okay, qualitative chemical analysis where you will be finding out the composition of the sample. So if it is under qualitative, it's qualitative and quantitative. Till now I have discussed qualitative methods of analysis, that is salt analysis, if it is inorganic method, and if it is organic method, we'll find out the functional group present in the given compound. Under quantitative chemical analysis, it involves the determination of composition by weights. So we'll determine the composition of the sample. We'll determine the amount of the sample present in the compound. See here, quantitative analysis is used to tell how much is in a sample, means how much of the compound is present in the sample. It involves the determination of the composition by weights. Quantitative chemical analysis is again of two types, that is chemical methods of analysis and physical methods of analysis. Listen here carefully. I have to teach you the chemical methods also before going into physical methods. As our chapter, here we are dealing with the physical methods, the two spectroscopic methods of analysis. But before going into that, I want to tell you what is this quantitative methods of analysis, that is quantitative chemical analysis. In this, we have volumetric methods of analysis. Under chemical methods of analysis, we have volumetric methods of analysis and gravimetric methods of analysis. When I told you that volumetric methods of analysis, you might have recollected that volumetric analysis which you have done in inter-second year, that is acid-base titration or redox titration which you have done. So here in this volumetric analysis, you might have estimated the quantities of the constituents present in an unknown solution. So it is determined by measuring the volumes of the solution. So first we'll be determining the volume, that is the volume which we'll be taking from the burette. So for this volumetric analysis, we'll be using burette and conical flask. So we'll be taking reading from the burette, that is volume. From that we'll determine the molarity of the known sample, a known solution. From that molarity, we'll determine the amount of that compound present in the sample. So what we are doing here ultimately, we are calculating the amount of the compound present in the given unknown sample. So from this we'll know that it is a quantitative estimation, quantitative chemical method. So why we are calling here chemical method? So if we take here chemical reactions, chemical reaction is involved. Means if it is an acid based titration, you might have done titration of NaOH and HCl. It is an acid based titration. In that acid based titration, we'll be taking acid and burette and NaOH in conical flask. We'll be titrating that. We'll be taking an indicator for that. So we can take methyl orange as indicator. After adding methyl orange to the conical flask, that is NaOH, the solution in the conical flask turns to pale yellow, and that solution, after titrating with acid, that is HCl, at the end point we'll be getting a color change. So it means that it has reached its neutralization point. Means the reaction is completed. Means the acid has reacted completely with the base. It means that the amount of that is the volume that we have pipetted out in the conical flask, it has reacted with the sufficient amount of acid from the burette, and when it has reached its neutralization point, we'll get a color change. Okay, so here it is a chemical method. Chemical method in the sense acid has reacted with a base. That is a volumetric method of analysis. Volumetric methods of analysis. Under volumetric method, I have explained only one method, that is acid base. We have so many methods, that is redox, complexometric, and so on. In gravimetric methods of analysis, that is under chemical methods itself, means that in gravimetry also a chemical reaction is involved. In gravimetric methods of analysis, the mass of the ion in pure compound can be determined. In gravimetry, if we have seen, if we means in inter, you might have not done that gravimetric methods of analysis. In gravimetry, there are different steps involved where no need to mention here that gravimetric methods of analysis. So directly I'll switch to physical methods of analysis. So till now I have taken the qualitative, quantitative methods of analysis. Under quantitative estimations, we have chemical methods and physical methods. Chemical methods briefly I have done because our chapter is the physical methods of analysis, that is physical quantitative methods. Okay, there are several methods available for the quantitative estimation of organic and inorganic compounds. Several methods are available. Primarily, the quantitative estimations are of two types. I told you already, chemical and physical. So, and physical methods of analysis, just I have mentioned in this table, that is chromatographic methods and spectroscopic methods of analysis. As it comes under quantitative estimations, you might be thinking that in physical methods also we'll be doing that quantitative estimations, means we'll be determining the amount of the compound present in the sample, but it's not like that. In chromatographic methods of analysis, there it is a separation technique. Chromatographic methods of analysis or separation techniques where TLC, thin layer chromatography, gas liquid chromatography, paper chromatography, HPLC, where it is a separation technique. Separation in the sense we can separate a mixture of compounds present in a sample. Means if we were given a mixture of compounds, how to separate those compounds, means how to get the desired compound. Desired in the sense we want a compound from that mixture. How to separate that? We'll be applying this chromatographic methods of analysis. Okay, in thin layer chromatography or gas liquid chromatography, paper chromatography, the chromatographic chapter itself is different, where there are separation methods where we'll be using a solvent to separate the compounds. So now I'll switch to spectroscopic methods of analysis. These are based on the measurement of electromagnetic radiation absorbed or emitted by an analyte. What is analyte here? I've started spectroscopic methods of analysis, and you have to note the difference between this chromatographic, spectroscopic, and volumetric and gravimetric. In volumetric and gravimetric, though it comes under quantitative methods of analysis, I have told you that the amount of compound can be determined. But when it is with physical methods of analysis, that is with chromatographic methods of analysis, I told you it is a separation technique. Separation in the sense mixture of compounds can be separated. Now here it is spectroscopic methods, spectroscopic physical method. Okay, in spectroscopic methods, I told you it is based on the measurement of electromagnetic radiation absorbed or emitted by the analyte. So these spectroscopic methods are completely instrumental methods of analysis. We can call this as an instrumental methods of analysis. What is electromagnetic radiation? I told you in spectroscopic methods of analysis, the sample will absorb some radiation, electromagnetic radiation, and depending on the absorption or emission of the radiation, will measure the type of compound present there. Okay, so now we have to know what is an electromagnetic radiation. As you all have studied in inter first year itself, an electromagnetic radiation was discovered by James Maxwell, and here it is nothing but an electrically charged particle. When it moves under acceleration, when an electrically charged particle moves under acceleration, alternating electric and magnetic fields are produced and transmitted. Produced and transmitted. These fields are transmitted in the form of waves called electromagnetic waves. Okay, I'll repeat that. When an electrically charged particle moves under acceleration, alternating electric and magnetic fields are produced and transmitted. These fields are transmitted in the form of waves called electromagnetic waves. Electromagnetic radiation is a wave with electric and magnetic field which are mutually perpendicular to each other. So when we describe a wave, how we describe a wave in terms of its wavelength or its frequency. What is wavelength? The distance between two successive crest or trough is called the wavelength, is known as wavelength. Okay, it is represented by lambda. What is frequency? The number of waves that passes a given point in a second is called frequency. Okay, so when we are going into electromagnetic radiation, we have to know electromagnetic spectrum. How an electromagnetic wave is produced, I told you. When an electrically charged particle move under acceleration, alternating magnetic and electric fields are produced. So this electromagnetic wave produces electromagnetic spectrum. So what is electromagnetic spectrum? The arrangement of all types of electromagnetic radiations. The arrangement of all types of electromagnetic radiation in order of their increasing wavelengths or decreasing frequencies is known as electromagnetic spectrum. Okay, in that electromagnetic spectrum, if it is an increasing wavelength, generally we'll be writing increasing wavelength and increasing frequency in that. So which one is having highest frequency? If we consider frequency into consideration, it's cosmic rays and gamma rays first. They are having highest frequency. After that, X-rays. After that, UV visible. After that, UV rays. After that, visible, infrared, near infrared, far infrared, microwaves, and radio waves. So, till now, I have explained that electromagnetic spectrum with increasing frequency. Which is having highest frequency? Gamma rays. Okay, so now what is the spectroscopic methods of analysis? What is spectroscopy? Spectroscopy may be defined as the interaction between the matter and electromagnetic radiation. So when matter comes in contact with this electromagnetic radiation, it behaves differently. The study of spectroscopy deals with emission and absorption spectra. As you all know, as you have studied in Inter, the emission spectrum and absorption spectrum. What is emission spectrum? Spectrum produced by emitted radiations is known as emission spectrum. What is emitted radiation? Emitted radiation in the sense, just now I told you that what is spectroscopy? It is defined as the interaction of matter with electromagnetic radiation. When a matter interacts with electromagnetic radiation, that matter may absorb that radiation or emit that radiation. So when a matter absorbs that radiation, we call that an absorption spectrum and produce a spectrum. When it emits in the sense spectrum produced by emitted radiation. The spectrum corresponds to the radiations emitted when an electron returns back to the ground state. Actually, I think that you know the ground state and the excited states of an electron. Okay, what is absorption spectrum? Spectrum produced by the absorption radiation. Absorbed spectrum produced by the absorbed radiations is called absorption spectrum. This spectrum corresponds to the radiation absorbed in exciting the electron from a lower energy level to a higher energy level. Okay, so here in this we'll be studying the absorption spectroscopy. All these methods means UV visible spectroscopy, IR spectroscopy, NMR spectroscopy, all these comes under absorption spectroscopy. So from this different types of spectroscopies, that is UV visible, IR, NMR, we will come to know the different types in the sense the different qualities of the compound. So as I told you, the spectroscopic methods of analysis are completely of an absorption spectroscopy. Now I want to teach you the fundamental laws of absorption. The fundamental laws of absorption. What are the fundamental laws of absorption? Laws of absorption. It is nothing but the first thing is transmittance. Transmittance is denoted by a letter T. It is the ratio of intensity of light transmitted by a sample to the intensity of light incident on the sample. So, a transmittance ratio of intensity of the light transmitted by the sample to the intensity of light incident on the sample.